How do you use Matplotlib's Plt.hist function? Imagine you have a bunch of numbers and want to see how they are spread out. Maybe you want to know if most of your data is clustered around a certain value or if it's spread evenly. That's where histograms come in handy. They give you a quick visual way to understand the distribution of your data. Today, we are going to explore how to use the Plt.hist function from the Matplotlib library in Python to create these helpful charts. First, you need to import the library. Usually, you write import Matplotlib, pplot as plt. Once you have that, you need some data. This data can be a list or an array of numbers. For example, let's say you have a list of test scores like this: 32, 96, 45, 67, 76, 20, 79, 62, 43, 81, 70, 61, 95, 44, 60, 69, 71, 23, 69, 54, 76, 67, 82, 97, 26, 34, 18, 16, 59, 88, 29, 30, 66, 23, 65, 72, 20, 70, 49. 73, 62, 87, 37, 68, 81, 80, 77, 92, 81, 52, 43, 68, 71, 86. To create a histogram, you just call Plt.hist and pass your data as an argument. Then, to display the chart, you call Plt.show. This will pop up a window with your histogram, showing the distribution of scores. The histogram has two main parts. The x-axis shows the bins, which are the ranges of data. The y-axis shows how many data points fall into each bin. By default, Plt.hist automatically decides how many bins to use, but you can change that. For example, if you want 10 bins, you add the parameter bins is equal to 10. If you want to set specific bin edges, you can pass an array of edges, like bins is equal to np, arrange 0. 10110, which makes bins like 010, 1020, and so on. This helps you control how detailed your histogram is. You can also set the range of data you want to include with the range parameter. For example, range is equal to 0, 100 will only consider data between 0 and 100. If your data has outliers or extreme values, this can help focus your view. Another useful option is density. If you set density is equal to true, the histogram will show the probability density instead of raw counts. This makes it easier to compare datasets with different sizes. You can also make the histogram cumulative by setting cumulative is equal to true, which shows the running total of data points. Changing the look of your histogram is simple too. You can specify the color with the color parameter and add labels for the legend with the label parameter. For example, Plt.hist data bins is equal to 10, color is equal to blue, label is equal to test scores will give you a blue histogram with a label. If you want to make the bars filled or just outlines, you can use the hist type parameter. The default is bar, but you can choose step or step filled for different styles. If you want to compare multiple datasets, just pass a list of data arrays to Plt.hist. For example, Plt.hist data1, data2, bins is equal to 10, label is equal to data1, data2, will overlay to histograms, making comparison easy. The function returns a tuple with three things: the counts per bin, the bin edges, and the patches or bars. You can use these for further customization or to add annotations. Creating histograms with Plt.hist is a simple yet powerful way to analyze your data visually. Whether you are checking for skewness, spotting outliers, or comparing datasets, this function makes it straightforward. Remember, adjusting the number of bins and range can help you get the clearest picture of your data. Practice with different options to see what works best for your specific dataset. With a little experimentation, you will be able to generate insightful visualizations that make your data easier to understand and share.